Welcome to this video on the topic of linear functions. In this video, we're going to have a look at two things. The first thing being, what is a mathematical model? And secondly, how we can go about constructing them. Now firstly, a mathematical model is a mathematical statement that's used to describe a real-world situation. Mathematical models are important as they bridge the practical with the mathematical context. And thus, mathematical modeling is the practice of explaining real-world phenomena using mathematics. Now, to construct mathematical models from real-world problems, we have 5 steps that we follow. Now, the first of these 5 steps is when we have a written problem, the first thing we do is we determine the unknown quantities as well as the known quantities. If we have unknown quantities, we assign them variables. Secondly, we identify the relationships between quantities and variables and arrange them in an equation form. So step 1 and step 2 are actually the hardest steps in the process typically. For step 3, it's all about solving. So what we do is we rearrange the terms within the equation such that the unknown quantities become the subject. Fourthly, once we've rearranged, we've effectively solved the problem, but we still need to check that our solution makes sense in terms of the original problem context. So say, for example, if you're counting ants and you find that the solution you come up with is you have 10.5 ants, then chances are you've probably got a problem there because you can't have half an ant. Or if you're counting cars, you can't have half of a car. So you need to make sense, or you need to make sure that your solution actually makes sense relative to the context of the problem. And finally, for step 5, if you're presented with a problem in a written form, then you need to respond to the problem also in a written form. So for step 5, you write your answer as a sentence. Alright, let's have a look at some examples. Example 1, we'll start simple. When a number is tripled and subtracted by 11, the value is 1. So we've got a worded problem here. Looking at step 1, we determine the unknown quantities and assign them variables. So, when a number is tripled and subtracted by 11, the value is 1. So what we're dealing with here is we have a number which gets tripled and then subtracted by 11, which is eventually equal to 1. So first thing we're going to do is we're going to assign the unknown quantities. Now we could just write x, but that's not very intuitive. Rather, what we're going to say is we're going to say let x be a number. There we go. So now we've got our variable. Next step is we need to evaluate we need to observe the relationships between x and the quantities also described in the equation or the problem. So we're going to say x, and then we say when a number, so when x is tripled, so it's going to be 3x because it's tripled, and subtracted by 11, so it's telling us to subtract 11, the value is 1. So 3x minus 11 will equal 1. So what we've done here is we've built a mathematical model describing this problem over here. Now, because although this isn't a real world problem, it's still employing the same steps that you would do if you were confronted with an actual real world problem. So we're still gaining the useful skills here. Alright, now step 3, rearrange in terms of the unknown, or in other words, solve for x. To solve for x, we're firstly going to move all our constant terms to the right and our variable terms to the left. So constant term 11 needs to go to the right by adding 11 to both sides. Then we're going to remove our factors. So we have 3x, but we want to know what is x. So we divide both sides by 3. The 1, that should be 12. So we're going to get 12 divided by 3 is equal to x, and therefore x is equal to a value of 4. So we can therefore say, therefore the unknown number is 4. So this is step 5 here. Write your answer as a sentence. So what you can see is that when a number is tripled and subtracted by 11, the value is 1. We have a definition of what we're trying to find here. So let x be a number. We have the mathematical statement or the mathematical model, 3x minus 11. And then we have the final part. So therefore the unknown number is 4. The only step I skipped in this was step 4. So check that your solution makes sense in terms of the original problem context. I was so excited when I was doing this. I'm so excited I got to the final value. I forgot to check. But from what you can see, it actually does make sense if you wrote this back in. So if you said 3, 4, minus 11 equals 1, what you're going to find is that 12 minus 11 is going to be 1 equals 1. So it works out. Okay, moving down, example 2. We have a scaffold tower is 4.1 meters tall. It can be increased by adding 50 centimeter sections. How many sections must be added to make the tower 10.1 meters high? So what we're first going to do is we're going to identify all the quantities within this problem. So a scaffold tower is 4.1 meters tall. It can be increased by adding 50 centimeter. How many sections must be added to make the tower 10.1 meters high? So scanning over again, a scaffold tower is 4.1 meters tall. It can be increased. So it can be increased by adding 50 centimeter sections. How many sections must be added to make the tower 10.1 meters high? So we're adding. Okay. Now, the context is we have, the tower. Let's say something like that. And what we're going to do is we want to make it taller. So at the moment it's only 4.1 meters. And what we would like to do is we would like to make it grow, so to speak. We want to make it grow to 10.1 meters. And the way in which we do this is we add 50 centimeter blocks or 50 centimeter increments. Like so. So the question at hand is, how many increments do we need? So unpacking the problem at hand. So we'll leave this nice illustration somewhere over here. Alright, so we've done the first part of the analysis. We've looked at the relationships. We've drawn a little diagram to help us along the way. And now it's time to construct the mathematical model. Now doing this, the problem at hand is how many increments. So we'll say let n be the number of increments or the number of sections. Alright, so now we're going to start piecing everything together. So a tower is 4.1 meters tall. So 4.1. It can be increased by adding. So plus 50 centimeter sections. So we're going to add 50 centimeter sections. And it's centimeters, so it's going to go 0.5. And then we're going to not just add 1, but we're going to add n amounts of these 50 centimeter sections. Now, when we add enough of these, the tower is going to grow to a height of 10.1 meters. Now the next step is we need to solve for n. So to do this, we move our variable, or we move our constant terms to the right and our variable terms to the left. It's got to go. This becomes 0.5, 10.1 minus 4.1. Then we're going to divide this, should be an n, divide this by 0.5. And thus, our value of n is going to come out as, we have 12. And remember, there's context to this. It's not 12, it's 12 sections. So we can say a count of 12 sections will grow the tower to 10.1 meters. Done.
It's the one and only Digo Double G. Snoop Dogg. You know I'm mobbing with the D.R.E. Yeah.